Okay, so class, first we look into this graph. Have you drawn the graph here? Yes or no? If you haven't, so I will give you some time to draw it. If already, then we can discuss together. So you draw a smooth curve like this, set 1 and set 2. Okay, class, if you look into these two graph here, set 1 and set 2, which one has a higher rate? Higher rate of reaction. Okay, so it's a set 2, set 2. Okay, set 2, why? Because it has a steeper gradient. Okay, steeper gradient. Okay, and then volume of the gas released also the same because number of mole will be higher. Okay, so next, so later, let's say you haven't tried, you can try again later. Now we look into the next question. Based on the graph, calculate the rate of reaction at 90 seconds. Okay, for set 1 and set 2. So at 90 seconds is here. So 90 seconds is here. So you draw a line here. So you draw a tangent. Okay, here for set 1, and then this one for set 2. Okay, so you draw a tangent. So you record down the coordinate here. Okay, x and y. Okay, so this one also the same. X and y. So x and y. Okay, so meaning that this one is 50. Let me see. This one is x is 147. Okay, y is 50. Okay, so for this one is 51. Y is 20, 30. So it's 25, is it? Okay, yeah, 25. Okay. Okay, how about this? This is 150. X. Y is 39. 39. Okay, how about this? This one is X is 42. Y is 15. Okay. So you list out the coordinate. Your coordinate may be different with this one. Okay, so you can use your own one. You can use your own one. So again, okay, we can calculate the rate of reaction for set 1. Okay, y, the volume divided by time. Okay, so set 1, have a look here. So set 1 is 0.22 cubic centimeter per second. So plus minus 0.1, meaning that your answer is accepted from 0.12 to 0.32 cubic centimeter per second. In this range, your answer should be no problem. Okay, then for the set 2, 0.26, that will be 0.16 to 0.36 cubic centimeter per second. Okay, so anyone you have tried already? So is your answer in this range, class? Is your answer in this range? Haven't tried, Okay, so if you haven't tried, you try again, Okay, when you are free. Okay, now, okay, I would like you to try this question. Average rate of reaction. So if you see average rate of reaction, meaning that no need to get from the graph, you can get from the data. So for set 1 and set 2, okay, everyone please calculate now for average rate of reaction for set 1 and set 2. So based on the table, okay, you can calculate. Okay, for set 1 and set 2. Okay, so for set 1 and set 2. Okay, so set 1, any one you have calculated for the average rate of reaction. What is your value, class? Can you type your answer or on your mic? Okay, 0.148. Okay, 0.148. How about the others? All can get 0.148. Same, huh? Okay. So meaning that the volume, what is the volume, class? Volume is 40, right? Okay. Time is 270. Correct? So 0.148 unit, no? Okay, cubic centimeter per second. Okay? Or you can round to 0.15, also can. Okay, how about set 2, class? Okay, 0. Oh, yeah, now different, huh? 0.204 or 0.181. Okay, which one is correct? How about the others? Belinda, how about you? Siyang? Darren? 204. Okay. Cubic centimeter, cm3, huh? Okay, now we see, okay. So you have to be careful. What is the time for the set 2? Okay, you see, you observe carefully, huh? Here 49, here also 49, meaning that at 240, huh? At 240, already finished, huh? Because 270 is also the same. Okay, so the time here is 240. Don't use 270. Okay, huh? So meaning that volume is 49 over the time is 240, huh? So you will get 0.204, huh? Seconds, around to 0.20. Okay. Okay. So class D1 based on the answer, compare the rate of reaction between set 1 and set 2. Okay, so what is the answer? Compare. So which one has a higher rate of reaction? So set 2, huh? Set 2. Simeon, one more reminder. If the question use the Roman 1 and 2, 1 and 2, like this, 1 and 2. We don't change it to 1 and 2, If you write like this, it's wrong, no marks will be given. So you have to follow the one. Okay, just remind you. Maybe you know already, So set 2 has a higher rate of reaction than set 1. Okay, like this. Any question, class? Okay. I think the collision theory, we come back later. Okay. So I want to use another method, or another notes to explain first. Okay. So this one we leave it first. Okay, we leave first. Okay. We go to the concentration factor. Okay. If higher concentration, okay, more number of particles per unit volume, higher frequency of collision between the particles. So higher frequency of effective collision and then higher the rate of reaction. In other words, higher concentration, higher rate of reaction. Okay, higher concentration, higher rate. Okay, so how do you know it's a higher concentration? Okay, normally you will see the unit for concentration is mole per cubic decimeter. Okay, this one. Sometimes you will see the unit, the acid. Okay, sometimes it's a strong acid or weak acid. That one you also need to be careful. Okay, we look into example. Example. Okay, there are given. It is given you two set of experiment. Step 1 and step 2. Study the effect of concentration. Concentration. Okay, so concentration normally is the solution. Solution or acid or alkaline. Okay, So here we see excess granules of zinc. Okay, so here zinc granules. This one also granules. Mean size is not affected. Okay, now here 20 cubic centimeter of 0.2 mole per cubic decimeter hydrochloric acid. Okay, this one 0.2 mole per cubic decimeter sulfuric acid. Okay, so just now I mentioned to you already, you may see the same concentration 0.2, okay, but different acid. Okay. So class, how about these two acid? Okay, which one has a higher concentration? Okay, here if we look into here is 0.2. This one also 0.2, but different type of acid. Okay, so which one has a higher rate of higher concentration, class? Which one higher concentration? Yes, set 2. What? Set 2. Okay, why? Why set 2? Yeah, the answer is higher concentration is this one. Okay, this one higher concentration. Okay, why? Strong acid. This one also strong acid. Hydrochloric acid also strong acid. Sulfuric acid also strong acid. What is the differentiate then? Stronger. Why it is stronger? What is the keywords for sulfuric acid? Remember the keywords? Hydrogen. Start with D. No, not dilute. Anyone know? Remember? What we call sulfuric acid is? Anyone remember? Darren, you remember what is the name, specific name for this sulfuric acid? Suyang, Belinda? We call it is not dilute, huh? It is called diprotic acid. Okay, diprotic acid. Apa maksud dia, What is the meaning of diprotic acid? Okay, so we list out, Okay, so sulfuric acid, when ionized in water, they produce the hydrogen ions and sulfate ions. Okay, so here is 2 moles of hydrogen ion. So we call this is the diprotic acid. It produces 2 moles of hydrogen ions. In other words, if here given to you 0.2, 0.2 mole per cubic decimeter, okay, then this is times 2 diprotic, meaning that this one will be double 0.4 mole per cubic decimeter. Is that okay? So in other words, the concentration becomes double for the sulfuric acid. Okay. Meanwhile, for the hydrochloric acid, this one HCl. It is strong acid also ionized completely, so it produces hydrogen ions and chloride ions. So this one we call it monoprotic acid, Okay. So in other words, if this one is 0.2 mole per cubic decimeter, this one also the same, 0.2 mole per cubic decimeter. Okay, same thing, same concentration. Okay. Okay, so you record down this one and this one. So this is diprotic acid. This is monoprotic acid. Yeah. So this concept, every year in the SPM confirm will be asked. So diprotic acid or sulfuric acid, monoprotic acid. Okay, if produce 1 mole of hydrogen ions. Okay. So ionic equation for the reaction. Okay, still remember how to write the ionic equation? Okay, we start from the chemical equation. Okay, so anyone will do. Okay, let's say we try the set one now. Set one. So zinc react with hydrochloric acid, right? HCl. So you produce zinc chloride and hydrogen gas or hydrogen gas. Oh, so we have to balance the equation this one times 2. Okay. In order to write the ionic equation, we need to know the physical properties. So zinc is solid. Hydrochloric acid is acid, right? Aqueous. Zinc chloride soluble or not, class? Zinc chloride. Is it soluble, sir? Yes or no, class? Zinc chloride. Chloride. P A H. PaH insoluble. So that is lead, silver, and mercury chloride. Okay, only these three are insoluble. Others all are soluble. So zinc chloride not in here, right? So this one is soluble. Soluble. So meaning that it is aqueous. Hydrogen gas is a gas form. Okay. So ionic equation, solid, liquid, gas, don't disturb. Copy down. Okay. So zinc is a solid, so copy. Aqueous solution, acid, you separate it to ions. Okay, so produce aqueous solution, soluble salt, and then chloride. H2O. Okay, so same ions, you cancel it. So chloride, same, right? So remaining is the ionic equation. Zinc with hydrogen ions produce zinc ions and hydrogen gas. Okay. Okay, huh? And then if you use the second one, okay, for this one, you try to write the chemical equation and then you also try to write the ionic equation. Is it the same or not? Okay, so everybody you try number 2. Write the chemical equation first, like this one, okay, and then you separate it to ions, okay, and then see whether you get the same ionic equation or not. Okay, you also try, everybody you try for set 2. Okay, so this one I erase. Maybe later I will show it here. Okay, so I all try to write for the set 2. Okay, see whether you can write the correct ionic equation or not. Okay, is it the same? Yes, it is the same, right? Okay. So in other words, actually any acid, okay, you just take note that the ions actually will be the same, there is the hydrogen ions, will be the same. So meaning that set 1 or set 2 ionic equation will be the same, Okay, good. Now, okay, B1, calculate the average rate of reaction for set 1 and set 2. Okay, so again, this chapter all asks you to calculate the set 1, the rate of reaction, set 2. Keep asking you to calculate the rate, and then ask you to explain using the collision theory. Okay, then why you try? Okay, so for set 1, what is the average rate of reaction? Volume divided by the time, volume divide by the time. 556. Okay, so average rate. So volume is 50, right? Time is 90. So you get 0.556 cubic centimeter per second. Okay, how about set 2? Average rate, 1.11, 1.11. Okay, so again 50 over 45. So it'll be 1.11 cubic centimeter per second. Okay, now compare the rate of reaction between the set 1 and set 2. So if we want to compare this one and this one, how are you going to write your answer? Okay, set 2 has a higher rate of reaction than set 1. Okay, very good. Set 2 has a higher rate of reaction than set 1. Yeah. So be careful here, must use a higher, don't use faster. Rate, don't use faster. Okay, so this one again, we leave it first, the collision theory. We come back later. Okay, now we look into this one. Effect of concentration on the rate of reaction. Okay, so the time taken for the fixed max of the sulfur form is shown in the table. Okay, so class, for this one, sodium thiosulfate with the sulfuric acid, just sodium thiosulfate solution with the sulfuric acid. Okay, it forms a sulfur. Okay, it forms the sulfur. Sulfur is in the solid form, So how are we going to measure the time for the X? Okay, so for this experiment, okay, I think I'll show you one video later. Okay, we will put it on a piece of paper. Okay, a paper. We put a mark here. A mark X here, cross now, and then we put the chemicals. Okay, here. Okay, we put it on the paper marked with X. So inside here is a mixture. Okay, you put it here, and then your eyes will be observed from the top. Okay, your eye. So your eye observe from the top. Okay, so sulfur is a solid. Okay, solid. So it will make or cover the X marks. Okay, so X marks is cannot be seen. Okay, then you record the time taken for the X cannot be seen. Okay, So I think I'll show you the videos. Okay, hold on. Let me share this. Okay, so to investigate the effect of concentration on the rate of reaction, huh?
Will it affect the rate of precipitation of sulfur? Let's find out. Click the buttons to start the experiment. Will concentration affect the rate of reaction between 0.2 mole per cubic decimeter of sodium thiosulfate and 2.0 mole per cubic decimeter of hydrochloric acid solutions? Key in your answer and click the Submit button when you are done. Click and drag the apparatus and reactants needed onto the table. These are the apparatus and materials needed for this experiment. Watch carefully how the experiment is carried out. Calculate the
Hold on.
concentration
I think this one is too fast a bit. Okay, once it is poured in, right? Okay, you see this one. Okay, so the formation of the sulfur, it will forms a light yellow color. It is the sulfur actually. So it will covers the X marks, right? So X mark cannot be seen already. So you record the time taken. Okay. So after that you repeat again for different concentration. So what is the time taken for the X mark cannot be seen here. Okay, huh? You observe from the top.
Calculate the concentration
So the
of
concentration
diluted
we
sodium
can calculate.
thiosulfate
Later
solution.
we calculate. Okay, we use the M1 V1 equals to M2 V2. Huh?
These are the times to plot.
Okay, then we plot the graph. Okay, now we try our own exercise here. Okay, so first we learn how to calculate the concentration here. Huh? Okay, so we use the formula M1 V1 equals to M2 V2. Okay, so this is for the dilution. Huh? M1 V1 equals to M2 V2. Okay, so here we see okay, M1 concentration, volume. So concentration, what is this one now? So initially is this potassium thiosulfate or sodium thiosulfate now be the same. Okay, the concentration of the sulfuric acid we fix it now. This one becomes a constant variable, huh? Okay. So how to do this? This one no water add in, so meaning that the first one, the concentration is 0.02, no change. Yeah. Okay, but for second one, you see here. Yeah. So we calculate for this one M2. M1 V1 equals to M2 V2. So M1 is 45. Right. Okay. Then concentration is 0.02. Initial one. Right. Okay. So M2 you need to find concentration. Okay, class, what is the V2? Volume after you add in the water, distilled water. So remember, is the original one is 45 plus the volume of water here is 5. Okay. So 50, right? So use your calculator. What is the value for M2? M2, 50, huh? 0.02. Okay, so what is the value of M2? Okay, anyone you can calculate? Okay, 0.018, huh? Okay, 0.018 mole per liter centimeter. Okay, so this is for set 1, huh? Set 2. Set 1, set 2, set 3, set 4, set 5. Okay. So this is for set 2. Okay, now anyone can calculate for set 3? What is the value? Set 3. Hmm. 0.016. All can get this value. So I show you one more time. Okay, so M1 is 40, right? Concentration set. M2, you need to find. So now is 40 plus 10, so it's still 50. Huh? So M2 is 0.016 mole per liter. Okay, so 0.016. Okay, now you calculate number 4 and number 5. Okay, after you calculate, you can type in your answer. 4 and 5. Okay, class. And now we look into this one 0.014, 0.012. Okay. Now for 1 over the time taken, you see here, the lower the concentration of the sodium thiosulfate or potassium thiosulfate solution, the longer the time, right? The time increase. So here, how to calculate the 1 over time? Very simple. It's 1 over the time, 18.5. Okay, so can you calculate what is the value? 1 over 18.5. We round to 2 decimal places. Okay, 2 decimal places. Okay, so what is the value, class? 1 over 18.5. 2 decimal places. So you will get 0.05, right? 0.05. Oh, correct. Okay, next. How about this one? 1 over 22.8. Okay, so you get 0.04. Okay, how about this one? 0.03. Next, 1 over 46.9, 0.02. Okay, this one 0.01. Okay, cannot? Okay, here. Okay, name the precipitate form from this reaction. The precipitate. Just now I mentioned already. So what is that? What is the precipitate? Yes, sulfur. Oh, sulfur. What is the color of the sulfur precipitate? What is the color? Yes, light yellow color. Light yellow. If you write yellow, also correct. No problem. Okay. Now, write the chemical formula for potassium thiosulfate. Okay, potassium thiosulfate. Okay, so what is the formula, class? Hmm? Okay, so class, potassium thiosulfate. Okay, potassium is K. Thiosulfate, S2O3. 2 negative. Okay, so what is the formula? Hmm? So I need one. If these two combine, what is the formula, class? Okay. Okay, good try, but it's not accurate now, not accurate. You have to be careful on the chart here. This one is 1, this one is 2. So, okay. So, how to, can you rewrite again, Simeon? Okay. Willie. Okay, your answer is correct. Your answer is correct. Just a capital letter you need to write. I think you should be able to write. So it's K2, S2, O3. Okay? Because these two should be here. 2, this is 1. Okay? So sometimes this one is not potassium, it's sodium. So sodium, if sodium with the 7, Na2, S2, O3. Okay? Now C, name the particles present in the solution of potassium thiosulfate. So what are the particles? You have to name. Okay. So potassium and thiosulfate. Okay. Actually, it's these two lah. So what is the name for these two? This one is what? What is K plus? What is K plus plus? Potassium what? What particles is it? Potassium. If it has a charge, it is ion. Yes. Okay. Another one. This one is what? Okay. So it's thiosulfate. Ions also. Okay. Okay, so this one calculate already. This one calculate already. This one. Okay, now plot a graph of concentration of the potassium thiosulfate solution against 1 over time. Okay, plus concentration of the potassium thiosulfate solution. This one is a Y, right? Y. So what is the unit for this? Plus, what is the unit for concentration? You got right? Okay, here. Mole per cubic decimeter. Okay, how about 1 over time? Per second. Unit is per seconds. Okay. So now I would like you to try to plot the graph in the graph paper here. Okay. And then draw the graph. Okay, everybody you try, try to plot the graph. Okay, done already, class? Okay, now we check together. Okay. So here you see, okay, concentration, unit stated mole per cubic decimeter. So here concentration. Okay. The best is we write the full one to be the best. Okay. And then this one is 1 over time. 1 over time. 1 over time per unit per second. Okay. So 1 over time. So this all need to be mentioned. Okay. So this one and this one. Okay. Next we have to plug in all the information. Okay. 1 over time. Okay. Concentration. Okay. 0.1. 0.01. So it's 0.12. Okay, like this. Okay. So class here, you see here, for this one, for this part, okay, for this part, actually no need to draw. Okay, no need to draw. You just start from here. Okay, why? Okay, so you just start from here. Okay. For this case, it's okay because if you extend it to 0, here is still a straight line. Okay, but sometimes in the exam, okay, you'll get a graph like this. For example, I show you an example. Okay, you'll get a graph like this. Okay, straight line. Okay, it's straight line. Okay, like this, correct already. But sometimes the student feel that it must be connect to 0, so they purposely extend it to 0 like this. Okay, draw again. Because like this, if you extend it to 0, okay, it becomes not a straight line already. So meaning that this part becomes wrong. Yeah? So this one is wrong. Okay, so meaning that in actual fact, we just plot the first point enough. Okay, so from the graph here, okay, the first point is 0.01, 0.012. Okay, so it's this one. Okay, so this is the first point. The second point, third point, fifth, fourth, and fifth. So actually, this one no need to extend. Okay, but here if you extend it here to here, it's still correct. It's still a straight line. You can, but in the SPM one, no need to extend. No need to extend to 0. Okay, you get what I mean? We will mark based on the points, meaning that okay. So this one is 0.1, 0.2, 0.3, 0.4, 0.5. So all the points is correct, so you get the full mark. Okay, but if you extend it to 0 here, then the line becomes not a straight line, then you'll be minus mark. Okay, so be careful on that. Okay, so you get a straight line like this. Okay, Alan? Any question? Okay, so class, because we want to make it like not 0 to no need to start from 0. Normally, if we want to make a bigger size, I think let me check yours. Yours is okay. Yours also correct. Okay. Okay, let me check. 0.012. Okay. Why we put it to not start from 0? You get Willie asked, why this one not start from 0? Okay. If like this case, it's still okay. It's still okay because we want to make the graph bigger. We want to make it bigger. But if you want to start from 0, actually it also cannot. Okay, 0, but your scale must be consistent. Okay, already? But sometimes, what my experience in the SPM, in SPM is very simple one. All the scale is given already. Okay, so you just need to plot on it. Oh, very simple one in SPM. Oh, okay. Let me check. Okay, next. Let's see what question. Okay. So class, let's say now if the question asks you, okay, what is the time taken, okay, for a concentration of, let's say 0.0219, okay, 0.021 mole per cubic decimeter. 21 mole per cubic decimeter. Okay, so can you find the time taken if the concentration now is 0.021? Okay, here is 0.020, right? Okay, so class, where is 0.021? It's here, right? It's here. Correct, huh? So 0.021. Okay. In other words, how to find the time? Our time is here. So you can extend it here, extend. Okay, we need it here. So use the ruler. Okay, draw a dotted line. Okay. And then you see what is the value here. Okay. So class, what is the value? What do you think is the value? 0.5, 0.055. Okay. But this one 0.055 is what? Is 1 over time, right? This one 0.055 is 1 over time. The question asks you what is the time. So how to get the time? How to get the time? Yes? Anyone? 0.055 is 1 over time. So very simple. Okay. But you need to remember 1 over time. Your answer is 0.055, right? Then how about time? If I want to find the time, in other words, exchange, right? 1 over 0.055. Use your calculator, you get 18.18 seconds. Okay? Seconds are X. Okay or not? So you have to know how to get the answer from the question like this. Oh, okay. Next question. So class, what is the relationship between concentration of the sodium sulfate solution and the rate of reaction? Okay. If you write directly proportional, okay. In physics, your standard answer must write directly proportional or inversely proportional, right? In physics. But chemistry, never write this word. Okay, we don't write directly proportional or inversely proportional. Okay. So in chemistry, we will encourage the student higher like this. Okay. To replace the directly proportional. Okay. So meaning that here, the relationship here, so the higher the concentration of sodium thiosulfate solution, the higher the rate of reaction. Okay, to replace the directly proportional. Is that okay? If we inversely proportional, one higher, one lower, like that. Okay, but don't use directly proportional. Okay, or inversely proportional. Okay, but if you want to write directly proportional, please add in tambah. You add in at the back. You write again. The higher the concentration of sodium thiosulfate solution, the higher the rate of reaction. Then it's okay. If you insist want to use the directly proportional, okay, huh? So the higher the concentration of potassium thiosulfate solution, okay, the higher the rate of reaction. Okay. Okay, huh? Let's okay. So collision theory, or you also skip first. Yeah, skip first. And now we go to the temperature factor. Temperature factor. So conclusion here: higher temperature, higher rate of reaction. Okay. Why? Because higher temperature, the particles they have higher kinetic energy, move faster. They can react faster. Okay. Now we look into the example. Okay. Temperature affects the rate of reaction. So you see here. Now concentration the same. Acid also the same. Right? Okay. Here powder. This one also powder. So no difference. But temperature is different. Step 1 and step 2. So class, which one has a higher rate of reaction? Step 1 or step 2? Yes, step 1, higher temperature, am I right? Higher temperature. So, if this reaction, okay, calcium carbonate powder, okay. So, what is the gas involved in the reaction? Calcium carbonate and the hydrochloric acid. So, what is the gas release? Carbonate, right? So, carbonate, you produce what gas? What gas is released? Anyone? Carbon dioxide, no? Yeah, so no need to think uh, for this. Carbonate, confirm it is carbon dioxide. Carbon dioxide. Okay, carbon dioxide. How to verify the gas? Verify the gas. So I mentioned already. So you need to mention two things. One is what? The first one? Okay. We know it is it is the lime water, but in your explanation you have to mention what things. What you need to mention in order to get 2 marks. For this one is 2 marks, right? Okay. Anyone still remember? What you need to include? If you write test with lime water, no marks, Okay. If you write test with lime water, no mark, 0 mark, Okay. So what you should write to verify? Okay, the first one is the action taken, Action. What action taken? Number 2, what is the observation? Okay. So what action taken? How are you going to test with the lime water? How? What action? the gas, how we do with the gas? We bubbles, right? Again, bubbles or deliver the gas into lime water, right? Okay, so this is action. Okay, action. Huh? So what can you observe? What happens to the lime water? Lime water turns milky or chalky, or cloudy. Huh? Okay. Milky also can. Huh? So remember, whenever you want to verify the gas, action and the observation. No matter what gas it is. Okay, now next. Calculate the maximum volume of gas liberated in the experiment. Okay. So first, you need to write the chemical equation first. So what is the chemical equation? Okay, so first, you must write the chemical equation. Okay, ready? So calcium carbonate with hydrochloric acid, right? Okay, so calcium carbonate, hydrochloric acid. So you produce calcium chloride, carbon dioxide, and water, correct? So we have to balance the equation. So this one is 2. Enough? So first, we must calculate the number of mole for hydrochloric acid. Okay. Because this one is excess, right? The calcium carbonate is excess. So we must calculate this one. So MV over 1000. Okay, everybody you calculate this. MV over 1000. Okay, so you get 0.005 more. Okay. Now the question asks you to compare with the volume of gas, right? So where is it? This one, right? So you calculate for this one. So you compare these two. So step number 2, mole ratio, So mole ratio. So 2 mole of hydrochloric acid produced 1 mole of carbon dioxide. If 0.005 more. So how many moles for the carbon dioxide class? 2 to 1 means half, right? 0.0025 moles. Okay. So here your mole is this one, Don't use this one, Don't use this one. This one is for hydrochloric acid. So next, number 3. Okay. So volume of carbon dioxide, 0.025 times the carbon dioxide, So is we use the 24,000. So you will get 60 cubic centimeter. CM3, huh? Because here use a CM3. If 24, it will be DM3, huh? So it's different. Okay. And now we look into this graph. Okay. So volume of gas evolved in the time. So set 1 and set 2. Huh? Okay. Now, can you calculate the average rate of reaction at 40 seconds for set 1 and set 2? Okay, average, average. For me, I think this question got problem. Okay, why? Because at 40 seconds, right? If I mentioned to you last week already, at 40 seconds, meaning that this one is an instantaneous rate. So actually, you cannot calculate directly from the graph like this. Okay? If a specific time, 40 seconds, what should you do here? So you should draw a tangent and then find the coordinate, then calculate the tangent for it, right? You have to have the coordinate in order to get the rate of reaction at the 40 seconds. Okay, but here this one is not a graph, so you cannot get points, right? Okay, so for this one you cannot get the uh, average rate of reaction. Oh, so I think this one got problem this question. Okay, never mind. We don't do this question now because it's the wrong question. Oh, because this one you need the graph. Oh, you need the graph. Okay, so compare the rate of reaction. Okay, this one explain your answer based on the collision theory. Okay, so this one we also skip this down. Okay, so we still conclusion here, higher concentration, higher temperature, higher concentration. Okay, so next factor is the catalyst. Catalyst. Okay, so before we look into the rate of reaction, okay, we look into the characteristics of the catalysts. Okay, so the first one, okay, the catalyst, it is very specific for one reaction only. Okay, the catalyst is very specific for one reaction only. Okay, for example, okay, hydrogenation. Okay, hydrogenation, it needs a platinum as a catalyst. Okay, Haber process, it needs the iron powder as a catalyst. It's a very specific, very specific for one reaction only. Okay. Number two, the catalyst only a small amount needed. You add in a little bit catalyst is enough to increase the rate of reaction. No need to add in a lot of the catalyst. No need. Okay. Number three, the mass and the chemical composition remains the same before and after the reaction. The mass remains the same, and then chemical composition remains the same. It won't change. Okay? But the physical may change. Okay? For example, the colors may be changed. Okay? But chemically, no change. And then the products, the quantity of the products remains the same. It won't increase the quantity of the products. It will only increase the rate of reaction. Increase the rate of reaction. Okay? So if got catalyst on the rate of reaction, it will have the higher rate of reaction. Okay? Now, we look into the sample questions. Okay. So for this one, Okay, 5 cubic centimeter of 20 volume of hydrogen peroxide. Okay, so hydrogen peroxide. Okay, we put in the glowing splinter. Does not light up. The glowing splinter does not light up. Okay, this is for set 1. If set 2, here we put in manganese 4 oxide. Okay, so this one actually acts as the catalyst. Okay, so once if you put in this one, okay, you will see if you put the glowing splinter here, the glowing splinter rekindles and burns brightly. Okay, okay, why? Why? So let's see. Okay, the chemical equation for the decomposition of hydrogen peroxide. So first, hydrogen peroxide is H2O2. So when it decomposes, so that's what do you think is the product? Try to have a guess. What gas it will make the glowing splinter rekindle? Yes, carbon oxygen. Another one, water. So got 2 products. When it decomposes, it forms the water and oxygen. So it's not balanced, so we have to balance it. So this one times 2, this one times 2. Okay, huh? So if it can decompose to form the oxygen, so it will make the glowing splinter rekindle and then it burns brightly. But if like this, no catalyst, meaning that it cannot decompose. No decompose, cannot decompose. Okay, meaning that no oxygen is produced. Okay, so what type of particles present in hydrogen peroxide? Okay, try to have a guess. Hydrogen peroxide, is it atom, molecule, or ions? Hydrogen peroxide. Class, what do you think? Okay, H2O2 plus. It is transfer of electrons or sharing of electrons plus. In order to achieve octet electron rating. Okay, sharing electrons, right? Okay, if sharing electrons, so what is the particles? Is it ions or molecules? Atoms not possible, right? Okay, because got hydrogen and oxygen, so not possible is atom. Yes, it's a molecules. Molecules. Okay, so compare the rate of reaction. Which one has a higher rate of reaction? Okay, so set 2 has a higher rate of reaction than set 1. Okay, so collision theory we skip also. Skip first. Okay, now here I want to explain on this. Okay, catalyst, it will provide an alternative pathway with a lower activation energy. Okay, so catalyst, it will lower the activation energy. What is it mean here? Is refer to these diagrams. Yeah. So this one is called energy profile diagram. Okay, energy profile diagram. Okay. So initially, hydrogen peroxide, when it decomposes, it will form the water and oxygen gas. Okay. So class. Activation energy is the energy barrier that must be overcome before you produce the product. In other words, okay, the activation energy for the original without catalyst is this one. Too high. Use your ruler. Like this. Yeah. So this one is the original one. So exactly touch the line here. So this one is the energy barrier that must be overcome. So we call this is the activation energy. So it's a EA. Okay, EA. Activation energy. Okay. For example, the activation energy needs 100 kilojoule EA. Meaning that all the collisions must be overcome 100 kilojoule or equals to 100 kilojoule, then it can produce a product. Okay, if less than 100, like say 99.9 kilojoule, it still cannot produce a product. It still remains in the molecule form, in the reactants. Okay, clear? Then, if we use the catalyst, okay, catalyst, the function is to lower the activation energy. In other words, it will make the activation energy lower. So which is this one, the second one? Yeah. So this one is, we call it EA prime, EA prime, meaning that activation energy with catalyst. Okay. So in other words, let's say initially it needs 100, but now if it is lower, meaning that with catalyst, okay, so now the EA only needs, let's say 60 kilojoule per mole. Kilojoule. Only needs 60 kilojoule, which is much more lower, lower. So in other words, just now 99%, 99.9 kilojoules still cannot overcome, right? But now all can overcome 60 already. So let's say here is 60. So more collisions, it can overcome this activation energy. Okay, so meaning that more products can be formed easily. Okay, that's why the rate of reaction is higher with the catalyst. Okay, or not, guys? Okay, huh? Anything, please answer. Okay, now. Next, okay, sketch a graph of volume of gas evolved against time for both sets of experiment on the same axis. Okay, so can you sketch the graph now for both experiment? Okay, so which set has a higher rate? So set 2 law, set 2. So in other words, yeah, set 2, I use two different colors, set 2, higher rate, set 1, lower rate. Okay, now the volume of gas released is the same or not, class? Is it the same? We have to see the number of mole, the condition. This one 1 gram, this one 5 cubic centimeter, 20 volume. This one 5 cubic centimeter, 20 volume. Okay, will be the same, huh? Will be the same. Okay, same number of mole. So meaning that okay, will be like this. Set 1 and set 2. You have to label it. Okay, but for me, okay, for me, although theoretical set 1, set 1 you release the gas. Okay, but practically I don't think you will release the oxygen gas, because you see, there is the decomposition of hydrogen peroxide is very, very slow. even not happen, okay, not occur, not occur without the catalyst, okay, macam tidak berlaku lah, okay, it won't happen actually without the catalyst. So for me, this one not very valid, okay, but theoretical, it still can, okay, huh? So we actually here we want to show it. It is the we want to show it, the rate of reaction, number one, and then the volume of the oxygen gas release is the same because the number of mole are the same. Oh, okay. Now, class, we look into the question number 2 here. Okay, we want to investigate the effect of quantity of catalyst on the decomposition of hydrogen peroxide. Okay, so here set 1 we use 0.1 gram, set 2 0.2 gram. Okay, although just now we say less little amount already can, but if you put like this, this one more than 0.1, okay, it's double, right? It's double. So meaning that we can see, okay, which one has a higher rate? Means it release the gas faster. Set 2, right? Set 2, correct? So if the mass of the manganese oxide used is higher or is more, then the rate of reaction is higher. Okay. Okay, so class number 1, what is the function of manganese oxide in this experiment? What is your answer? What is the answer? What is the function of this catalyst class? What is one? It is as a catalyst, catalyst. Oh, so if you see sometimes you see one extra things or extra chemicals add into the reaction, so it is as the catalyst. Okay. Now number 2, name the gas liberated in this experiment. What is the gas? Okay, this is how we mentioned already, huh? So the gas now is the oxygen gas, right? Okay, oxygen gas. Name oxygen gas. Okay. Now, verify, identify the gas. Okay, again, number 1, you need to mention the action. Number 2 is the observation. Okay, so now, can you try this to verify the oxygen gas? You ready? So what is the action taken, class? What is the action taken? A glowing sprinkler. So action, place a flowing splinter into test tube containing the gas. Okay, so you have to mention the action. No? Don't write test with flowing splinter. Okay, no marks. So what is the observation? What is the observation? What happens to this flowing splinter? Flowing splinter? You got answer, right? Flowing splinter rekindles, right? Okay, enough. Rekindles. Rekindles or relighted. Okay? So remember, huh? So we revise again for oxygen. Just now is the hydrogen, huh? Just now is carbon dioxide. Okay. Another one normally is the hydrogen. So need to know. Okay. Today's last question. Okay. So calculate the average rate of reaction for both reaction here. Average rate of reaction for set 1 and set 2. Set 1 and then set 2. Okay, so class for set 1, what is the value? Average rate of reaction. Okay, you get 0.19 cubic centimeter per second. Okay, how about set 2? Set 1? Set 1, 0.19. Let me check. Set 1, yeah, set 1 is correct. Okay. Set 2? 0.33. Okay. Set 2, volume is 45, time is 210. Right. So it's 45 over 210. Is it 0.33? 0.21, right? 0.21 now. Okay. Okay, so in our today's lesson, we have talked about the factors, or the 4 factors actually, but we haven't covered the collision theory. Okay, so next week we are going to look into the collision theory. Okay, and then some application. Actually, this chapter is almost done already. Okay, so that's all for today's lesson. Thank you, class. Okay, good night to all of you.